And the first thing I want to ask you is, who here likes to play video games? Okay, cool. Well, the first thing that I want to talk about is there's a problem with video games. And not just video games, but the whole entertainment industry. They spend millions and millions, if not billions of dollars on animators. And you're playing that game and you see a little thing walk by you. Some guy had to sit there, moving it frame by frame. It's very, very expensive to pay people to do this type of work. And these numbers are going up dramatically as technology increases. I want to ask you, how much do you think it costs to produce a video game today? What's the average cost? It's $10 million. And that's been going up exponentially. That's like 4 or 5 times what it was last year, and then roughly that since the year before. The general rule is if it can, it must. If you can have something really good, then it's got to have it, otherwise the competition will kill it. So we're sort of driving up cost, driving up cost, driving up cost. So yeah, towards more artists, animators, less programmers. Lots and lots of money again. So, how can we solve this horrible problem? Well, in my opinion, a few good programmers can replace a lot of artists, as you can see by this little diagram. That is, it takes roughly 6 artists to equal 1 Dilbert, in my opinion. And this is actually used sort of by Pixar, and what they do is they hire programmers to make the art for them. They'll make little programs that can generate a lot of art that they use in their movies. But what we want to do is we want to talk about animation, not about art. We care about how could we make something move realistically and do that automatically. So let's define the problem. I think the fundamental problem in animation is walking. I say we want something to be able to walk without specifically animating it. Why? I say walking is sort of the base animation. If you can't get something to be able to walk, then you don't have any hope of getting something to be able to do much more complicated than that. So, how do we do this? Well, highest level, we sort of describe the body of whatever it is in full detail and let the computer calculate the rest. Okay, but how do you do that? Okay, so first of all, how would we describe something that walks? So we need some sort of a body or morphology like these, which resemble humans. They have segments that are connected by joints, and the joints can move in certain ways and can't move in other ways, and you want to sort of explain how all that fits together. And then you have control. You have a nervous system that's connected to all these, a brain that sort of tells it, okay, if you want to walk, move your leg this far, so on and so forth. And this slide we should probably skip over, but the point is that I want to make is that the nervous system is sort of symmetrical to your body. That is, the same part of the brain controls this arm that controls this arm, same part of the brain controls this leg that controls this leg. Sort of intuitive, but this is a fundamental building block of this technology. But aside from that, let's just talk about the body and sort of this brain that we have set up. That's all that really matters right now. All right. Okay, great. So we have this sort of description of what a body is and a description of what a brain is, but how do we get it to walk? So big intuition here is Charles Darwin with survival of the fittest. So what we're going to do is we're going to make a bunch of sort of these random brains, and we're going to have them try to walk and see which one can walk the best. And whichever is the best, we're going to let it sort of, we're going to take that and change it a little bit and see if, what results from that can walk even better. So if this is confusing at all to you, let me show you this really cool video which sort of demonstrates how this works. So here's the first sort of random guy who can't walk very well. And then a few generations later, you'll see it's getting slightly more and more capable over time. But it's still falling over, so it's still not very smart. 10 generations. Almost there. And 20 generations. And we have an almost perfect one. And there was no artist that was involved in this. Oh, these pictures aren't supposed to be here. But does it work? And obviously, by what I just showed you, it probably works. You take that as proof. But the first guy to do this was Carl Sims, who worked at the MIT Media Lab and later for Thinking Machines Corporation. And this was adopted by this company called Natural Motion, which put it into commercial use. And their technology is famously featured in a Pepsi commercial called Glue Boy, which you might have seen. And it features a guy, and he's he's attached to a building with some glue on his hands, and they hand him some Pepsi, and he drinks the Pepsi, and then he falls backwards, and the glue keeps attaching. I don't know, it's a funny commercial if you've ever seen it, but it was done using their technology. And Will Wright's new game Spore uses the same technology. It'll be the first game to hardly have any animators at all. It's almost all generated automatically. So yes, it does. It probably does work, and it's being used out there by people. And do we have any questions?
I didn't understand what happens between the generations that makes the figure walk.
Okay, so we can go back to that. The idea is, it's the same thing as the evolution of a creature, and I'm sure you've studied like Darwinian evolution at some point in your high school career, where the parents have some sort of capabilities and they have children, and the children will have similar but slightly different capabilities, and then those children can have similar but slightly different, and so we sort of have more and more, if you think about kids being made, and all these children can compete with one another. And so the one that does the best will have the most kids. It's not the way it really works in real life, but if you talk about like tadpoles or animals, that's the way it works. That was a really bad explanation. But.
Computers don't have children, exactly.
Yeah.
So you're saying that you try these different programming things, and the ones that work better, you try variations of them,
yeah.
and the ones that don't work as well, you discard, is that right? That may be a link that was missing, calling it just children. Well, how was that? You notice he used some nice techniques with the slides. He kept changing them every few. There were times when the slide, it seemed almost like a dance between him and the slide. You do this, and he's gesturing with the thing, and the slide changes. Just adds a couple of words, that's all. So that was a very dynamic, interactive way of using the slides. And it worked, I think, for this kind of a presentation, it worked very well. If you're ever giving a presentation on detailed mathematics, probability theory, you probably don't want to use that kind of a presentation. But something you guys can rip off and use, and all he's using is the segueing feature. And is this PowerPoint or?
Yeah.
In PowerPoint. What else worked about this?
I like his excitement when we're talking. I thought the video was also very cool, just to give some more visual explanation.
I thought that there were a lot of different things you talked about, and maybe quite all of them.
Concepts I found.
Spend more time on just explaining the concepts.
I realized one of the slides I definitely should have cut out.
Can I see
Like
that title
that
slide?
I just sort of avoided anyway. What?
Can I see the title slide?
Yeah.
Yeah, I guess I didn't have any idea where it was going in the beginning. You asked what were video game, were you into video games? And I was like, okay, it's mainly about video games. But then you started talking about art. I think this is kind of relating to your point, so I make it more clear in the beginning what exactly you're going to talk about. I don't think that title really does the topic justice. You can pick a title that maybe is more engaging or more interesting to the students.
Yeah, you definitely should do that. In fact, let me tell you something. The students, if we do it like in past years, the students are going to look at the titles and decide to go which room they want to go to. And your room might be empty because, they'll look at Procedural Walkers.
I admit, I don't even know it. I wouldn't even know what that means.
They'll say, what's that?
I've never heard that
Okay,
term before.
you just got a
I just got all of them.
All right.
How about how to make smart video games? Because that's
Yeah.
what genetic algorithms.
Yeah.
I mean, they get smarter at walking. They get smarter
Okay,
at
I'll
chasing.
think of a
targets.
name.
Yeah, you can take that under advisement and think about it. But, there you
Yes.
go. Good one.
Something later.
And a lot of people have very effectively used the title plus a subtitle, where they have the main title and then they have a subhead as well. Like you could say video games, making robots walk or something like that, and tie it in that way.
I had to leave for a little bit during the presentation. I was wondering if you went into any technical detail about the techniques used in genetic algorithms or neural nets or training or anything.
No, you didn't.
We might be able to do a little bit of that. Let me go ahead and get set up, and let me give you just a little bit of a dump on the things I wrote down. I like that you began by saying with who plays video games, but I agree with the concerns that were raised also. You got to get the focus in quickly. I like the quick view graph flips. You were excited about your topic. The screen dialogue prompts was good. I would use the word evolution, even though they should know who Darwin is. I would use the word evolution, which is the root of what you're saying, and not risk that some of them think that Darwin is I don't know, a politician in the next town or something like that. And actually, I was wondering whether you might be able to get a copy of that commercial, whether on their site you could download the commercial, and you could even consider if it's 30 seconds or something, or just a snapshot of it, start with that and say, how do you think they get this to happen? You know, this was, you know, how many people would have to draw for how many hours in order to get something like this happen? Video games cost millions of dollars, and if you could do programming instead of spending, having hundreds of people work on it, think of how good that would be. Well, that's exactly what happens. And that sort of fits I like that about your style. You asked a question, you gave the answer. So I'm trying to mimic your style as I give you the feedback.
Another idea that might be helpful is to go into movies. So like, how many of you have seen Lord of the Rings? Well, Gollum acts very realistically, but it turns out that there's a guy who wears sensors, and computer animation artists really take sensors and like mimic his walking motion. Now imagine we could just get a computer to generate it, then some guy wouldn't have to wear sensors and walk around to simulate walking or simulate like some other smart movements, and like that might be a way to relate into your topic of genetic algorithms. Okay, the show must go on.
Are you not